over here. So we said, okay, format the size end problem. This is what my method is going to look like. So I'm actually just going to copy this code here, go down here, paste it in. Now, I guess I should note here, this is making the kind of the analysis method seem really simple. Keep in mind that it's not always going to be this simple, but this is just kind of our first kind of full example from this, so since we need some place to start. Okay, I'm going to again do a copy paste. Like I said, it's going to be more complicated when you have a real problem, but we'll start with this. All right, so display list is going to be a recursive method. First thing I need to do, right, is check my base case, right? I want to make sure that I can actually finish something, right? I want to stop at some point. So over here, right, I've already figured out what the stopping condition is going to be. And so if I have that, I can go ahead and return from the method. So I have that, so I know now this thing is going to stop if I run it. And then what I need to do, right, is I need to print out the current node, right, and then display the rest of it, right? I need to do a little bit of work, right, a little bit of work to make my problem simpler, and then I need to call myself again on the subproblem. So in here, right, what I'm going to end up doing is I'm going to do system out.println of node.getElement, right? So I'm doing a little bit of work to print out this first node. And then after that, right, I can go and I can call myself recursively. And this is the same code up here. I'm just typing it here just because. So display list of node.getNext. So this is our recursive implementation, right? So in this case, right, this looks a lot like the Fantastic Four analysis we did earlier. Now let's go ahead and try running this. So I'm going to take this off. I'm going to try print list instead. Or actually, let's go display list to use the proper name there. And we also need to make that public and static so that we can actually use it. And then let's run it. And over here we get 5 and 7. While we're at it, right, while we're kind of practicing our code, let's go ahead and jump into the debugger for a second just to see how this thing works. I'm going to set a breakpoint here on line 20. So this is going to pause my program, right? So once I've set up my little mini list, right, I'm going to go over here and kind of watch what goes on as I run this thing. All right, so I've set up my list. I'm going to go and call my recursive method. So initially, right, head is of the linear node that contains the number 5, right? It's the first node in my list. So let's go ahead and go inside that method and see what's going on exactly. So jumping over here, still looking at that first node, right? The node that contains the number 5. And then I do the check, right? I compare that node with null. Well, initially that node is not null, right? It's actually something to look at, so that ends up being false, right? And I kind of move along, right? I don't need to do anything else. The next thing I do, right, since I didn't have to return there, right, since I have some work to do, right, I didn't hit my base case, is that I need to print out something, right? So I need to print out that first value, right, the first node in that list. So I'll go and do that. And over here, right, you can see, right, the green, right, is indicating the line I'm currently on, right? I just executed line 27, and the next one to execute is 28. But down here, right, you can see that first thing, that first call, right, it's printing out the number 5, right? So that println got the first node. The next thing that happens, right, is I do have my recursive call. So my recursive call, right, it's calling the same function again, or that same method again. And then here this time we're doing node.getNext. So let's go ahead and try that. Over here you'll notice that we are inside the method again. And over here, because we did that, kind of that parameter was set as node.getNext, the parameter being passed in now is 7, right? So it's that second node, right? We've advanced forward by 1. So now node is 7. Again, we check to see if it's null. It's not, so we skip forward and keep on going. Then we do the println, right? So we print out that particular node. So print that node, get its element, display that 7. Now we're at the last line, and we need to do the recursion again. So this time, if we look at node, we see that it's equal to null, right? Remember that we created a list of 2 elements, and then at the end, right, there's always going to be a null there that says, oh, this is where you stop. So at this point, right, we've done a dot next twice, right? Dot get next twice, so we're at the end. So in this case, right, node equal null. Well, that's it, right? You have to return. So returns from the call that printed out the last thing, returns from the call that printed out the thing before, and ends up back at the main, right? Ends up back at line 21, and the program completes. So you can see kind of the trace, right, is that we recursively called it and we worked our way through the list and we updated node each time, right? This is, right, this line here, right, is working similar to this line over here. This line over here, right, is working similar to this line over here. This may not be a really good example of recursion simply because this isn't super simple compared to this. But hopefully it's something that lets you see kind of a more general uses of recursion, right? Rather than just looking at mathematical functions. Because really that's what we want to do, right? Is we don't want to just write solutions to problems that are, defined on a piece of paper as a mathematical function, but we want to do real things, right? So a list is kind of a more reasonable thing to look at in terms of how recursion can be used. Simply because lists are recursive data structures, so it makes sense that we might consider using a recursive algorithm or recursive method to do stuff